Problem 13.182 involves block A that's released from rest and slides down this frictionless surface of B right here until it hits a bumper to right hand side right there. Block A has a mass of 10 kilograms and B has 30 kilograms. And B can roll freely on the ground. Most of us determine the velocities of A and B immediately after impact when A part is E equals 0 and the B part is E equal to 0.7. So we're given M sub A equal 10 kilograms, M sub B is 3 times that, or 30 kilograms, and H is 0.2 meters. Since there are no external forces or impulses in the X direction, we can have conservation of linear momentum in X, which means we start off with zero velocity. We'll end up with MA VA prime plus MB VB prime, where these velocities are velocities after impact here. Or we can rewrite that as zero equal to, since VA prime and VB prime are going to be together because this sticks right here because the coefficient of restitution is 0, then we can rewrite that equation as MA plus MB times one velocity because of the same velocity for each term right there. And we're going to get VB prime equals 0, excuse me, V prime is equal to 0 out of this, which means that the velocity of VA prime is 0 and the velocity of VB prime is 0. Now we're going to do a little bit different approach here and work this problem again for the A part and the B part. We're going to look at it where we don't put in a value of E into the equation. We just leave it as E, and we're going to plug in values later on for it. So our equation again, this is still true right here. MAVA prime plus MBVB prime, but we can't assume that they're going to be stuck together. So it's assumed that there is a coefficient of restitution then, of non-zero restitution. So we plug in our m's here. This is 3 times that one right there, so that's why the 3 is appearing in this equation. So this equation can be rewritten as VA prime plus 3VB prime equals 0. And our coefficient of restitution equation would become VB prime minus VA prime divided by VA minus VB. Now this VA and VB right here are the velocities of A and B just before the collision takes place right there. So we can rewrite that as E times VA minus E times VB equal to VB prime minus VA prime. And what we can do is, if we take a look at this equation right here, we can add from this equation right here, we can see that VA prime is equal to a negative 3 VB prime. So if we stick that into this equation right here, we'd have VB prime minus, and then it'd be a minus 3 VB prime, which makes it plus 3, and end up with 4 VB prime out of that. So we have the equation then at E VA minus EVB equal 4 VB prime. Now we're going to look at the conservation of energy for the part where we're sliding down the surface, because there are no non-conservative forces doing work on the system while this slide is taking place. Now that's just before impact though, that we have conservation of energy. So the kinetic energy at the beginning is 0, the potential energy is mg times h, and that's m sub a times g times h. And then T2 is 1/2 mVA squared, MAVA squared plus 1/2 mBVB squared. And there is no potential energy there because we chose a 0 level to be at this point right here, this level right here. Okay, if we take a look at simplifying that equation, we can multiply by 2, and we can also substitute in the VB, or MB is equal to 3 times MA, and we can cancel out all the MAs, and then the 2 multiply across and give us a 2 over here, so we'll have 2GH equal to VA squared plus 3 VB squared. Now, we have conservation of momentum before collision. There's still a conservation of momentum expression we can write down, and that is 0 starting off equal to MAVA plus MBVB. And remember, the VA and the VB is before collision takes place. Or we get this expression that VA is plus 3VB is equal to 0. So let's go back and look at our equation right here. We bring it down, 2GH. And for VA squared, we're going to put in a minus 3VB squared, which is going to become a 9 VB squared when everything gets squared. And then we have plus 3 VB squared right there, gives us a total of 12 VB squared. And so when solve for VB out of here, we're going to get the square root of GH over 6 involved, because and solving for VB out, that's what you get. And you choose a negative sign because B is going to be going in the negative direction, A will be going in the positive direction just before impact. So when you look at the fact that VA is 3 times VB, or the magnitude of it anyway, no, it's actually V sub A is equal to minus 3 VB. So there's the minus and there's the 3 to give us a plus sign here. Okay. Now, we have that VB prime from this equation right here is equal to E over 4 VA minus VB. So there's the E over 4. VA has a square root of GH over 6 right there. VB has a 1 right there with the minus sign. So that minus sign there and that minus sign there is going to turn into a plus. And so we end up with this, E times the square root of GH over 6. So VA prime then, in general, after collision, is going to be a minus 3E square root of GH over 6. And VB prime is going to be equal to a plus E square root of GH over 6. This is the way it works out in the equation. So when you put in E equal to 0 into these two equations, you get each one of these having a 0 velocity then. And when you put 0.7 in right there and 0.7 in right there, you'll get VA prime equal to a negative 1.201 meters per second, and VB prime will be equal to 0.400 meters per second.